Taking the indefinite integral of a function is the same as taking the antiderivative of a function. The only difference now is that we have proper notation. Now that I know about the fundamental theorem of calculus, I understand that integration is the opposite, or it's basically the inverse function of differentiation. So it undoes whatever differentiation does. So now I use this integral symbol to denote that I am taking the antiderivative of a function. And it works exactly the same way as I had been doing when I had just been calling it antiderivative. I undo what the differentiation does, and I add a constant at the end because the constant is lost during differentiation. The only way I can get this constant back is by solving for a point, and then whatever is left over from solving for that point, that will be the constant for that particular integral. Now the difference between definite integrals and indefinite integrals are definite integrals are over a particular interval, AB, and the answer I get is a number, while indefinite integrals, they're not over any set points, or it's not over a particular interval. Now obviously it can be integrated over the domain of whatever function it is, and most of the time it's going to be integratable over all of it, except for a point where there might be a hole in it. So it's very similar to definite integrals. I'm just not saying what the interval is. So while it's the same thing, my answer is not a number, but a family of answers. And the reason it's a family of answers is because this constant can be anything. So I might get something like, let's say, I integrated it and it was x squared. X squared plus c. So I integrated something and then it was equal to x squared plus c. Now x squared plus c can be anything. It could be x squared plus 0, it could be x squared plus 1, like this, x squared plus 2, minus 1. But that's the only real difference between the definite integral and the indefinite integral. Otherwise, it's just the same as taking the antiderivative.